So like I said, I'm going to talk about the procedure stuff right now, and then once you've entered in your hour of cooking, then I will talk about theory and mechanism and all that good stuff. So the first thing you want to do is the dry setup, which it looks like a lot of you are well on your way. Everybody that got pretty far made a mistake. It doesn't matter, but just so you know the difference of the glassware. All we need is the air condenser. What you folks have is the water jacketed condenser. It really doesn't matter, but this is the air condenser, just so you do know how to distinguish it. Okay. Dimethyl sulfoxide is the solvent for this reaction, and it has a very high boiling point. I'm going to say near 200. So what that means is that and the other materials in this reaction don't really have any vapor pressure, so it means nothing can go out the top if you got an air condenser. We use the water jacketed one when you got things that are a little bit volatile, and if we don't, run cold water through there, stuff's just going to evaporate out the roof. Yeah. Okay, so we got that. We're going to use the 10 mil round bottom flask, RBF. It's called RBF a long time before RBF meant something else. So that's a bottom flask. I forget, what do I call for? Is it the peanut stir bar? Or?
Yeah.
Okay. All right. Okay, so what's that? We're going to join these two joints together. Those are called ground glass, and I can't see through them and stuff. What's the most important thing we'll remember when we're joining these guys together?
A lot of force.
That's a good one. I wasn't thinking of that one, but that's a great one. We never force glassware, because if it breaks, your hands are going towards each other and you'll stab yourself. I've seen that happen. But these ground glass joints, so that they don't come apart, you need a little blue nut. And what else? The O-ring, yeah. If you don't, your reaction can just plunge, drop, break, spill, do over. As I always advocate, it's good to make your setup all dry, don't get any chemicals, and then once your setup is all done, then you can, take whatever part you need out to go get chemicals. Yeah. Okay, so these are really cool. Not a lot of, even the glassware we use in the laboratory for research and stuff, you can't suspend it like this, but these you can suspend because of that little O-ring. And the 10 mil round bottom flasks fits nicely in one of the divots in the aluminum thingamabob. We can monitor our temperature with one of these, with these guys, because the temperature is not going to exceed 150 degrees Celsius. If it does, then you can't use them. So it can go right in that hole on the side there. It looks good. And I didn't put the stir bar in there, but you have the stir bar in there. Okay? So that's how that guy's going to look. And then into asterisks where I wanted to tell you stuff. The TLCs that we're going to do are a little bit different than the TLCs we did first semester. First semester they were plastic backed. Okay, these are glass. All right, they are more expensive, so it's okay if we have to redo one. It's not uncommon, but let's try not to. Let's try to be pretty careful. Remember, we want to centimeter up because. Centimeter up because the big mistake you can make with TLC plates sometimes is you've got the eluent in your chamber is too high, and then you dunk this thing in, and that line is underwater, so to speak. Okay, and you don't want that; it just dissolves off, and TLC doesn't work. So the critical thing is once you put this into the chamber, that line is above the eluent level. Okay, if you follow the directions, it should work out. 1 centimeter up, and then I think you put in 10 mils or 7 mils, I don't remember, into the chamber and stuff like that. Okay. And then this will run up when you're all done and everything. And then we're going to stain, camphor doesn't have the necessary requirement of a molecule to be able to see it under UV light, okay? That trick we did before. What does a molecule need in order to absorb UV light? Alternating double bonds, okay? If you've got one double bond, it ain't really going to cut it very well, okay? But if you've got alternating double bonds, like in a benzene ring, or something called an enone, an enone is a ketone and an alkene, where the alkene and the carbonyl are in conjugation, so you get resonance. Another way to look at it is any place you can get, well, no, because a single double bond can have resonance, but you only absorb UV light. You really need more than one double bond in conjugation with each other. So we don't have that in camphor nor boreal, so we can't see these things. They won't absorb UV light. These have the green glowing stuff, but since the molecules can't absorb UV light, the whole thing will just turn up green. So we can't use that technology. So what we have to use is a stain. We're going to stain this, and then we're going to heat it up super duper hot to be able to visualize it. But I'm going to wait until we get to that point, and then I will, sort of walk whoever is ready first. I will walk you through doing a demonstration and stuff like that. Okay. All right. Okay. TLC. Good. Hirsch funnel. So this is the Hirsch funnel. I don't have one up here, but remember that there's a little rubber gasket that goes in here that this guy sits in, so that it makes a good seal. Okay. When we're using the Hirsch funnel and the blue vacuum thingy things, what do we always remember to do? So that we don't ruin the blue vacuum things? I'm working here 12 years. We haven't replaced one of those yet, I don't think.
Don't be shy.
What's that?
Have another Erlenmeyer class.
Yeah. Set up a trap. I don't know what just happened there. In any case, this guy, the Hirsch funnel himself, with his blue little adapter guy, he should be clamped. But the second Erlenmeyer flask, which I don't think I have either. Okay, so, all right, so to set up our trap, we put that guy in there, or actually before I put him in there, I'm going to get a couple of these rubber hoses. This is a real easy place to stab yourself. You go to the ER, so let's not do that. Okay, so you got your rubber hose, and the bad way to do it would be like that, okay? Leave a lot of distance here. The good way to do is hold it right at the very end, and just put it in that rubber hose with twisting motion, and it just needs to be in there a little bit. You don't have to, impale the thing down in there, okay? And then on the other side as well, okay? Now that those guys are all, actually, I will probably now go up to this dude. This one can sometimes be hard depending on how big the side port is. You can use just a tiny bit of water or soapy water there, and it'll slip on a little bit easier. Again, not a lot of force, twisting and maneuvering, okay? And then actually I would probably attach the Erlenmeyer last. Attach this to the vacuum, and then very last thing, we screw that guy just a little bit snug, and now he's ready to go. Anything that gets through here and gets into the tube will end up in the Erlenmeyer flask, not in the pump. Make sense? Cool. All right, and the really unusual thing about this is we're filtering this. Every other time we've filtered in the class before, we were trying to catch particulate product. Okay, we were trying to, that was what our solids were going to be that we catch in the top of the Hirsch funnel. Okay, In this situation, what we're catching in the top of the Hirsch funnel is actually the byproduct of the oxidant. Okay, so that's not our product. Our product is actually going to be down here. Okay, it's just a way to separate the byproduct and our desired product. Okay, don't forget to put a piece of paper in here. The paper's up there, a little circular paper. Okay. Once we've gotten that byproduct, we can separate that and everything. We're going to put it into a culture tube. We're going to do some liquid extractions to get more of the, primarily to get the DMSO out of there, the dimethyl sulfoxide. Okay, shake, shake, shake. Different layers, stuff like that. You got 2 culture tubes. It's pretty clear in here. You do it just like this. Okay. At the very end, you're going to have in culture tube B, I guess you can call it. You'll have your product dissolved in organic solvent, in the hexane ethyl acetate solvent, and you can actually TLC right out of there to see what your product mixture looks like. Okay. You may see, it's not uncommon to see a little bit of starting material if the reaction didn't quite go to completion and stuff like that. But yeah, we'll talk more about that when we get to the TLC part. That's it. Any questions? Let's do it to them.
Do you have a copy of this procedure?
I do.